GCSE Physics boosters, and this video is about voltage. There's current, voltage and resistance are the three things you really need to get your head around. I think current is pretty straightforward. Voltage is a little bit trickier. You know, when you get your head around it, there'll be an enormous rosy glow of satisfaction, but it is a tricky subject. It's not easy. Voltage. Listen carefully. Before we talk about electricity, I think it might help to consider a little bit about gravitational potential energy. If you look at this diagram, there's a kilogram at A and there's a kilogram at B. Now, a kilogram at A would have more potential energy than a kilogram at B because it's higher up. So we say that there's a potential difference between A and B. Yeah, a kilogram at A would have more potential energy than at B, so there is a gravitational potential difference between them. Now, looking at this circuit, hopefully that will help you understand what's going on here. A coulomb of charge, remember that current is the flow of charge, and you have coulombs of charge flowing round this circuit anti-clockwise. Yeah. Now, a coulomb of charge at A has more electrical potential energy than a coulomb of charge at B. And then that has more electrical potential energy than a coulomb of charge at C. What's happening in this circuit is that the power supply, every coulomb that flows round the circuit, the power supply gives it electrical potential energy. Then when it flows through each component, that electrical potential energy is transferred into other things. For example, in the resistor, it's transferred into heat. In the bulb, it's transferred into heat and light. So there is a potential difference between A and B. That means that a coulomb of charge at A has more energy than a coulomb of charge at B. There is a potential difference between them. This power supply will give 6 joules of potential energy to every coulomb that flows through it. How do I know? Because it's got 6 volts written on it. That's what volts means. We'll talk about this equation later. When I do electrical power, we'll come back to this equation, but it's basically what I've just said. The energy transferred is equal to the charge multiplied by the potential difference, or the voltage. We'll come back to that later. So voltage. Voltage is measured in volts. Potential difference is the same thing. You can say potential difference or PD or voltage. It is the same thing. It's measured in volts. We can talk about the voltage supplied by a power supply. For instance, this battery is a 9-volt battery, okay? Or the voltage across a component. For example, this bulb has 12 volts across it. Yeah, across, voltage across, not voltage through, okay? Current goes through things, voltage is across things. If you put a voltage across something, then a current will flow through it. Yeah, if anybody says the voltage through something, then they don't understand physics very well. This might help. Look at this. There's a petrol station. There's lots of cars go through the petrol station, then they do lots of different things. They drive to the shops, they drop the kids off, they visit Uncle Ernie, or sorry, Uncle Eric. This week it's Uncle Eric. And maybe this will help you to understand voltage. It's an analogy. If you understand what's going on here, you might understand electricity a little bit better. You have a think. What does the petrol station represent? What does each car represent? What does the petrol represent? How many litres of petrol each car is given, and the rate of flow of cars. So I'm going to show you the answers in 3, 2, 1. And there you go. Okay, the petrol station is the power supply. The petrol station gives chemical energy to the car. The power supply gives electrical potential energy to each coulomb. So a car represents a coulomb of charge. The petrol represents electrical potential energy. How many litres of petrol each car is given is the voltage of the power supply. And then the rate of flow of cars is the current. To measure the voltage across a component, we put a voltmeter in parallel with it. Okay, what we're actually doing is we're measuring the difference in potential energy between those 2 points, as in before and after this resistor. Okay, remember, voltmeters in parallel, ammeters in series. Yes, voltmeter in parallel, ammeter in series. There's a couple of rules for voltage which you should definitely remember. Even if you don't understand why, just remember them. Now, in a series circuit where you've got components one after the other, the potential difference of the power supply is shared between the components in the circuit. So if the power supply is 6 volts, then in this case 4 volts plus 2 volts equals 6 volts. Yeah, the voltages across the components have to add up to the power supply voltage in a series circuit. In a parallel circuit, the rule is that if components are in parallel, then they must have the same potential difference across them. If you look between points A and B, this resistor and this bulb are in parallel, they must have the same voltage across them, which in this case is 5 volts. A lot of students find this circuit a bit confusing. If I use a pen here, you'll notice that these components are in parallel, so they have to have the same voltage across them. If I was to look at a loop, now this is a loop all the way around here, and in that loop 5 plus 7 equals 12. So we're not breaking our first rule. Here's another loop. Ooh, let's go around this way. And again, 5 plus 7 equals 12. But in this case, what I'm interested in is this: components in parallel must have the same voltage across them. Here's a couple of examples for you to have a go at. So pause the video, and the answers are in 3, 2, 1. There you go. Okay, quickly talk about them. In the first one, series circuit, so that plus that must equal 9. So that's 5, so that must be 4. Very straightforward. This one, everything's in parallel. So 10 volts, 10 volts, 10 volts, everything's in parallel. And this is the tricky one, similar to one I did a minute ago. So now if that's 2.4, that must be 2.4 because they're in parallel. And then if we look at a loop, going round a loop there, okay, that must be 6 minus 2.4, which is 3.6.